So let's do some calculations here. We're going to go back to P1, and the inner product that we're going to use is the one we used for the example earlier, the integral from 0 to 1 of the product of the functions. And let's have my x vector be the polynomial 2x minus 1, and the y vector be the polynomial 3x plus 5. And let's find a bunch of things here. First, let's find the length of x and y. So the norm of x, which is the length, is the square root of x inner product with itself. That's the square root of the integral 0 to 1 of 2x minus 1 squared. And that's going to be the integral of 4x squared minus 4x plus 1, which is the square root of the integral. Actually, we can work out the integral now. The integral is going to be 4/3 x cubed minus 2x squared plus x from 0 to 1. And let's see here. We plug in 1. We're going to have 4/3 minus 1 is going to be 1/3. So that means we have 1 over root 3. That's the length of x. The length of y is the square root of y inner product y. Again, we do this fun little integral here, 3x plus 5 squared dx. That's the integral of 9x squared plus 30x plus 25. And that's the square root of 3x cubed plus 15x squared plus 25x from 0 to 1. And let's see here, that's going to be 43. So that right there is the length of y. Let's find the distance between y and x. So the distance of x to y, it's the norm of y minus x. It doesn't matter which order you subtract them in here. So that's going to be the square root of the inner product of y minus x with itself. So let's see here. What happens when you subtract these two functions? 3x minus 2x is x. 5 minus negative 1 is going to be plus 6 squared. So that's going to be x squared plus 12x plus 36 is square root 1/3 x cubed plus 6x squared plus 36x from 0 to 1. And let's see here. That's going to be 42 1/3. So 127/3, I believe. So anyway, so that's just the distance there. What if I now want to find the angle between x and y? Well, for that, we use cosine theta is the inner product divided by the product of the two lengths. So the inner product is the integral 0 to 1, 2x minus 1 times 3x plus 5 dx. We know the length of x here. We know the length of y. And let's see here. We do that integral. It's going to be the integral of 6x squared plus 10 minus 3 is plus 7x minus 5. This will be the square root of 43 over 3. And then that's going to be 2x cubed plus 7 halves x minus x squared plus minus 5x from 0 to 1. And let's see here. 2 plus 7 halves minus 5 is going to be 1/2 on top. And so then we divide here. And then we do our cosine inverse. and I'm getting 82.4 degrees. So this is just a sample of the things that we can ask you to calculate. And again, to me, I think it's really cool that we can have polynomials, which you can't really visualize as vectors, as directions, and yet we can still do this and find an angle between them. So in some sense, this vector 2x minus 1 and this vector 3x plus 5, they have 82 degrees between them in some way of graphing this. But regardless, the main point of this section is just to understand first off the definition of an inner product and an arbitrary scenario, and secondly how to do these types of calculations with that. We're going to especially need these calculations for the next section when we learn about the Gram-Schmidt orthonormalization process, but I'll save that for a later video.